welcome to another module in this massive open online course. So, we are looking at IIR filter structures. Let us continue our discussion by looking at another form, that is the cascade form. Okay. So, we want to start looking at the cascade form for IIR filter representation. Okay. And what happens in the cascade form is that we have our transfer function Hs, which is a rational function, okay, in Z, that is Pz over dz, and these polynomials are factored into first and second order factors. These Pz and dz, these are factored into first and second order factors. And for instance, let us say this is given as h of z equals, well, p naught into 1 plus beta 1 1 z inverse divided by 1 plus alpha 1 1 z inverse, all right. This is the canonical form. 1 plus beta 1 2 z inverse plus beta 2 2 z raised to minus 2 divided by 1 plus alpha 1 2 z inverse plus alpha 2 2 z minus 2. So, we do this, and this can be realized as follows. The structure for this so you can see this is a cascade of several terms, all right, several first order and second order terms, all right. So, we have p naught times a first order term times a second order term, all right. So, this is the constant gain p naught, this is your first order term, and this is your second order term. And this can be represented as follows. I have xn, cascade of one system after the other. So, xn, let us put it this way, goes through again p naught, correct, and then we have z inverse and we have the adder over here, and this will go to another gain. This gain will be beta 1 corresponding to the numerator. This will go to the adder. We have another gain minus alpha 1 1, where alpha 1 1 is a coefficient in the denominator, all right. And remember, this is a cascade, so this will continue, all right. And let us continue this below, and so this cascade will continue, and you will have here another adder, and this will be minus alpha 1 2 z inverse. Similarly, you will have here and you will have another adder here, and this gain is beta 1 2, and this is the adder, this is the output yn, and you will have another term that is Z inverse. This is beta 2 2, and this is minus alpha 2 2, and you have, well, of course here you have adders, so you have the adders, okay, and well, this is minus alpha 1 2 beta 1 2 minus alpha 2 2 beta 2 2, and here, so let us denote this point as 1. So, this point is basically 1, just to indicate that it is continuing, all right. So, basically this is the first order term, remember. So, this is the cascade, this is your first order factors. So, you have to factorize this, this is the first order factor, and this represents your second order factor. And this represents your second order factor, okay, all right. So, that basically shows the cascade form, representation of the IIR filter structure, all right. Let us do an example to understand this. Let us go back to the example that we have considered previously. So, this is our cascade form example. And what we have is, we have Hz equals 1 minus half Z inverse over 1 minus 7 by 8 Z inverse plus 3 by 32 Z minus 2. This is equal to 1 minus half Z inverse over 1 minus 3 by 4 Z inverse into 1 minus 1 by 8 Z inverse, correct. And therefore, I can write this as two factors. One is a first order factor, this is basically your, separate this into two factors, 1 minus half Z inverse, in fact both of them will be first order factors, times 1 over 1 minus 8 Z inverse. So, both of these are first order factors, and the representation is as follows. So, we have this your x of n all right, and that will go here, you have a delay, you have a delay Z inverse, okay, and here you have the gains that are basically minus half, and here you have the gain that is 3 by 4, and that is going inside the adder, correct, okay. And this is your first factor, and then the output is basically again this goes into Z inverse, and this is 1 over 8, and the output of this is basically nothing other than your yn. All right. So, this is the first factor. All right, this corresponds to your 1 minus half Z inverse, correct. You can see each of this is the df2 representation, 1 minus half inverse over 1 minus 3 by 4 Z inverse, and this factor is your 1 over 1 minus 1 by 8. This is your 1 over 1 minus 1 by 8 Z inverse. All right. So, that is what we have. This is the example of the cascade form. So, cascade form, this is your cascade of the example, that is basically which is 1 minus half Z inverse over 1 minus 7 by 8 Z inverse plus 3 by 32 Z raised to minus 2. Okay. So, this is the example of the, so this basically is the example for the cascade form. And now, let us look at another form for IIR implementation. This is the parallel form 1, all right, in which we decompose it into a sum, right, a partial fraction expansion of various factors. Okay. So, we have the parallel form 1, okay, and let us again consider Hz equals Pz over dz, and now we perform a parallel fraction expansion in Z inverse perform a partial fraction expansion in Z inverse. So, we can write or rather express Hz as Hz equal to gamma naught over, or this is gamma naught plus gamma naught 1 over 1 plus alpha 1 1 Z inverse plus, this is the second order factor gamma out naught 2, gamma out 2 gamma 1 2 Z inverse by 1 plus alpha 1 2 Z inverse plus alpha 2 2 Z minus 2. Okay. And therefore, what you can see is that we have split it into a sum, a partial fraction expansion of the first order and second order factors. Okay. And the structure of this parallel form, this can be given as follows. So, you have xn. So, now you will have these parallel branches. So, you have the first one, that is the gain gamma naught, then you have the gain gamma naught 1, and this is yn, and here you have the delay Z inverse, and you have minus alpha 1 1. This is the df1 representation of the first term, and then you will have the second order factor, and the corresponding representation will be you will have this Z inverse, all right, and you will have this gain gamma naught 2, you have the adder, and another adder over here, and finally you will have this joining this branch, and this is naturally given as this gain is, you can see this is gamma 1 2, all right, and this is going to be, you have 2, this is minus alpha 1 2, and this is and this last gain here is minus alpha 2 2, all right, and therefore, you have this various, and this is basically your parallel form. You can see this is basically your parallel form 1. Okay, just making sure that we have no errors here. It's alpha 1 2 minus alpha 2 2 gamma 1 2 gamma 0 2, and this is basically your parallel form 1. Okay. All right. So, basically what we have done in this module is we have essentially looked at these several examples. We have introduced the cascade form, looked at an example, also looked at the parallel form, and we will continue this discussion in the subsequent modules. Thank you very much.